Hello, so today's question is climbing stairs. Let's read the question first. You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? Okay, so let's open paint. Let's assume this as a arch staircase. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the initial case of n equal to 2 or n equal to 1. For 1, we can have one step, simple as that. For 2, we can have one more step as well as we can directly jump. So this gives us two ways. Now for n equals to 3, 4, 5, 6, 7, 8, 9, 10. For n equals to 3, we need we need to go to step 2 at least and then go to step 3. Okay, so uh, we saw in how many ways we can reach step 2 was by doing this. This is one of the ways. This is the second way to reach. So this gives us a total of two ways. Okay. And extending on this to reach step 3, we can go from step 2 to step 3 like this. And the second way, we can move one step. So this gives us 1 plus 1 plus 1, 1 plus 2, and this and we also have a, sorry, 2 plus 1. Another case is 2 plus 1, and the third case should be 1, where we climb one step only and then we jump two steps. 1 2, so giving us a total of 3 steps. Fine. So our basic intuition is we need to reach the previous steps to go to the third step. Now, if we know how many steps we are taking to reach to first step or to reach to second step, we'll know how many steps it would take to go to the third step. It is really simple actually. Okay, so we need to find, so let's define the function count. Suppose count gives us number of ways to reach. Count to reach where? N minus 1 steps. Okay. So as we saw earlier, uh, from the second step, itself, we can go to the third step. So count of how many ways we can reach the second step plus, sorry, plus count of how many ways we can reach the first step. Okay. And this will give us how many steps we can reach the first step. So this is the basic intuition. Now we can solve this using recursion. Okay, so our basic intuition is that we need to find n minus 1 plus count n minus 2. Okay? Now the simple thing is the base case. It's a recursion. This forms a recursion problem. So we'll have a base case. Base case is what? If n equal to 1, return 1. N equal to 2, return 2. So this will form our base case. Let's run this in. Okay, so okay, so we can have the first case if n equal to 1, return 1. If n equal to 2, return 2. Otherwise, return climb stairs n minus 1 plus climb stairs n minus 2. Okay, let's run this. Okay, so this will give us the correct output, but let's see the time complexity of this. This calls the recursion again and again, and this will give us TLE, which is time limit exceeded. Now, to solve a simple recursion problem, we can have we can simply, we can simply just use dynamic programming, the memoization technique or tabulation technique in dynamic programming. So how this works is we'll maintain an array which will store what this array stores number of ways to reach each step. So suppose zero stair, no no steps should be taken, so zero. Now for first step we need one. For second step there are two ways. For third step so there are three ways. Similarly for four steps, how many ways can we have? So it would be count of n minus 1 plus count of n minus 2. So n minus 1 is the 3 and 2. So this will give us 5. So to reach to reach the fourth step, we can have five different ways in which we can reach. Similarly, now eight and so on. So this will keep on giving us the number of ways that we can reach the nth step. Now, uh, now the thing is we need to store these values, store the value of count n minus 1 and count n minus 2 so that it can be reused later. So how can we come up by doing that? We can simply declare a vector as I did here. This is a normal vector that we can declare. Now, to store it, we can simply write the code as follows. For int I equal to 2, because we know the number of ways to reach 0 and 1. So from I equal to 2. From 2 we are computing. I equal to 2. Let me just copy paste this snippet, paste it over here. Okay, for I equal to 2, dp suppose is the name of this vector. dp of 2 should be equal to dp of this one and this one. So dp of 1 plus dp of 0. Okay, so we can store whatever value we have in this, and it will go on till nth step. So we'll have a whole list of arrays till n. Yeah, which will give us in how many ways we can reach the nth step. So the our final solution would be the value that is stored at the location index n. Okay, so this was the basic intuition and solving of the question climbing stairs. Thank you.